Ever wondered how your browser fetches websites from the internet or how you receive emails in your inbox? The secret lies in the intricate dance of requests and responses between clients and servers. This is the essence of client-server architecture, a computing model that forms the backbone of many network applications. From web browsing and email to database management systems, it plays a pivotal role in our digital lives. Stay tuned as we dive deeper into the fascinating world of client-server architecture. First off, what are clients in the context of client-server architecture? Well, clients are essentially the requesters or the askers in this whole setup. They're typically the devices or software applications that you and I interact with on a daily basis. There are desktop computers, our laptops, our mobile phones, and even our smart TVs. But it's not just the physical devices that make up clients. It's also the software applications running on these devices. Think of your web browser, like Chrome or Safari. When you type in a website's URL, your web browser, acting as a client, sends a request over the internet to the server hosting that website. Email clients, like Outlook or Gmail, also act as clients. When you hit send on an email, your email client sends a request to an email server to deliver your message to the recipient's email server. The recipient's email client then requests the email from their server, allowing them to read your message. Even the apps on your phone, like Instagram or Twitter, are clients. When you open these apps, they send requests to servers to fetch the latest posts or tweets for you to see. So, what's the role of clients? Well, clients have two main responsibilities. The first is to send requests to servers. These requests could be for a web page, an email, a database entry, a video file, or any other type of data or service the server can provide. The second responsibility of clients is to present the data they receive from servers in a way that's understandable and usable for us, the end users. When you visit a website, for example, your web browser receives data from the server in the form of HTML, CSS, and JavaScript. It then interprets this data and presents it to you as a fully formed, visually pleasing web page. In summary, clients are the intermediaries between us, the users, and the servers that hold the data and services we want to access. They send requests on our behalf, receive responses from servers, and translate these responses into a format we can understand and interact with. So in essence, clients are the requesters in this architecture. They're the gateways through which we access the vast resources and services available on networks, and they play a crucial role in making the internet and other networked systems user-friendly and accessible. Now that we know about clients, let's turn our attention to servers. Just as clients are the requesters in the client-server architecture, servers are the providers. They're the heavy-duty computers or processes that are primed to manage a variety of tasks. Servers are designed to be powerhouses. They boast higher processing power, memory, and storage capabilities compared to their client counterparts. This makes them well-equipped to handle multiple requests from various clients simultaneously, without breaking a sweat. Let's take a look at some examples. File servers, for instance, are dedicated to managing disk drives. They're the ones you turn to when you need to store, retrieve, or transfer files over a network. They're like the librarians of the digital world, efficiently cataloging and retrieving information on demand. Then there are network servers. These servers manage network traffic, ensuring that data packets reach their intended destinations without a hitch. They're like the traffic cops of the digital world, directing the flow of information across the network to prevent data jams and bottlenecks. And then we have database servers. These servers are responsible for storing, retrieving, and managing data in a database. They're the ones that power your favorite apps and websites, providing them with the necessary data to function. They're like the chefs of the digital world, cooking up the right data to serve you the information you need. But servers aren't just about brute force. They're also about finesse. Each server is programmed with specific business logic, enabling it to process client requests and perform necessary actions. Whether it's retrieving a web page, querying a database, or sending an email, servers are designed to handle these tasks with precision and efficiency. Therefore, servers are the backbone of this architecture, handling the heavy lifting. They're the ones that ensure your requests are met, your data is safe, and your digital world keeps spinning. Without servers, the client-server architecture would simply be a concept and not the powerful computing model that it is today. The glue that binds clients and servers together is the communication network. This network is the conduit through which the data flows, and it plays a pivotal role in the client-server architecture. In its simplest form, a communication network can be as compact as a local area network, or LAN. Picture a small office setting where all the computers are interconnected. They can share resources, exchange files, and communicate effortlessly. This is a LAN in action, a network confined to a specific area, usually not much larger than a single building. But let's expand our horizons. Imagine a multinational corporation with offices around the globe. They need a network that spans continents, connecting their clients and servers across vast distances. This is where wide area networks, or WANs, come into play. The internet itself is the most expansive example of a WAN, linking computers and servers worldwide. Whether we're talking about a LAN or a WAN, the communication network is the lifeblood of the client-server architecture. It allows clients to send requests and servers to respond, facilitating the exchange of information that is the essence of this architecture. But it's not enough to have just any network. The network must be efficient, capable of handling the data traffic without bottlenecks. It needs to be secure, protecting sensitive data from prying eyes, and it must be reliable, ensuring that the communication between clients and servers is uninterrupted and smooth. A robust and secure communication network is crucial for the smooth functioning of the client-server architecture. So how does this all come together? How does client-server architecture actually work? Let's take a journey through the steps of a typical client-server interaction. First, it all starts with a request. Imagine you're sitting at your computer and you open your web browser, the client, to visit your favorite news website. The browser sends a request to the server hosting the website, asking for the specific web page you want to view. Next comes the server's role in processing this request. The server, a powerful computer or set of computers, receives the request. It interprets what the client is asking for, and then it gets to work. If you're asking for a web page, the server finds that page in its storage. If you're querying a database, the server runs the necessary computations. Basically, the server does whatever is needed to fulfill the client's request. Once the server has done its job, it sends a response back to the client. This response could be the web page you wanted to view, the results of a database query, or just a confirmation that your email has been sent. The server's response is what fulfills the client's original request. And finally, the client presents the server's response to you, the user. If the server sent back a web page, your browser displays that page for you to read. If it was a database query result, your application shows you the data. If it was an email confirmation, your email client lets you know that your message has been sent. And there you have it, the client-server model in action. This model of request, process, response, and display repeats countless times every day, making everything from web browsing to database management possible. It's the backbone of our networked world, and it's all thanks to the efficient, powerful, and flexible design of client-server architecture. That, in a nutshell, is how the client-server model operates, making our daily internet tasks possible. Now, one might ask, why use client-server architecture? What are its advantages? Well, let's dive right into the benefits of this essential computing model. Firstly, we have scalability. Servers are robust and designed to handle multiple client requests simultaneously. If the demand increases and the load becomes too high, you can simply add more servers to the system. This capacity to scale up or down makes client-server architecture a flexible choice for businesses of all sizes. Next up is centralized management. With a central server acting as the hub of operations, updates, user activity, security policies, and other management tasks can all be conducted from a single point. This centralization simplifies the management process, reducing the potential for errors and inconsistencies. Then there's efficiency. In a client-server model, resources and tasks are distributed among multiple computers. This distribution optimizes the use of computing resources, preventing one machine from being overloaded while others sit idle. It's a smart way to ensure that all components are working together harmoniously, maximizing productivity. Finally, we have flexibility. Different clients, each with their unique capabilities and roles, can interact with the same server. Whether it's a lightweight mobile app or a heavy-duty desktop application, they can all communicate with the server using suitable protocols. This flexibility allows a diverse range of devices and applications to work together seamlessly, enhancing user experience. So there you have it. Scalability, centralized management, efficiency, and flexibility. These are the key advantages that make client-server architecture an attractive choice for many businesses and organizations. It's a model that balances the workload, simplifies management, and accommodates diversity, all while maintaining a high level of performance and reliability. These are just some of the reasons why client-server architecture has become a cornerstone of modern computing. It's a system that continues to evolve and adapt, proving its worth in our increasingly digital world. In conclusion, the client-server architecture is an integral part of our digital lives. We've explored how clients send requests to servers, which in turn process these requests and respond with the appropriate data. This dance of communication happens each time we browse a website, send an email, or use a networked application. Remember, this architecture offers scalability, centralized management, efficiency, and flexibility. Next time you browse a website or send an email, remember the intricate dance of requests and responses happening behind the scenes. Thank you for joining us today. Until next time, happy computing!